Hello everyone, welcome to this session. Today in this video we are going to understand in multi-threading in Java, and then we are going to solve a problem in it. This is the problem that we are going to solve. Before understanding what is multi-threading, I'm going to explain a few basic concepts. First, we'll start what is the CPU. CPU is basically a laptop's processing unit. It is a brain of the computer which executes the instructions. If you're using a calculator or you're performing an arithmetic operation or any logical operation, CPU does that. It's the brain of the computer. It gives the input and output operations specified by the instructions. Moving on, what is exactly a CPU? A modern CPU is what we are going to understand. A modern CPU has processing cores, like for example Intel Core i7 or AMD Ryzen 7. These are processing cores. A core is an individual processing unit within the CPU. They have multiple cores that perform multiple operations at the same time. So, we are going to move forward and understand what processors. The quad core processor, a common processor name, is known as it has 4 cores, allowing it to perform 4 tasks simultaneously. For instance, if one core can handle your web browser, the other is going to play the music in the background, and other is going to download. It's going to be the download manager, and another will play a background system again. Image. Today, now we are getting a clear idea what exactly a core is. Due to the time constraint, I am moving forward with the next concept, which is what is a program. A program is a set of instructions. You are writing a program for it to perform something. It is going to perform that task. Basically, it has instructions. It is written in various programming languages like Python, Java, JavaScript, Ruby on Rails, Kotlin, and many other languages. Microsoft Word is a program that allows users to create and edit documents. Moving on to what is a process. A process is a program that is being executed. When a program is not being executed, it is just stable at a condition. It is a program that is not being running. But the moment the program starts running, this is a program and it has now started running, the program becomes a process. So, a process is an instant of a program that is being executed. When a program runs, the operating system creates a process to manage its executions. There is going to be multiple processes in a program. There can be P1, process 1, process 2, and process 3, or there can be multiple programs. For example, if you open Microsoft Word, it becomes a process in an operating system where you can read, write, and edit documents. Moving on to a next slide, what is a thread? A thread is the smallest unit of execution. Basically, a thread is a process. Process can have multiple threads. From now, the chronology we have understand is program. When it runs, it becomes a process, right? So a process can have multiple threads. A process have multiple threads which share the same resources, but they can run independently. A thread is being allotted to print a statement, whereas another thread is going to write something, while another thread is going to read from the main memory, and another thread is just going to go in a loop. So there are multiple threads. This is a program which contains processes, and the processes can have multiple threads, with threads having different kind of work allotted to them. Now, these threads can run together. Like if we understand what threads are, a web browser like Google Chrome might use multiple threads for different tabs. Each tab is running as a separate thread. You have this tab where you have your chat GPT on, you have this tab where you have YouTube on, you have this tab where you have your Twitter on, you have this tab with your Claude code on. So these tabs are nothing but separate threads that is running in your background. All of the tabs are active. When you switch on the tab, you see that this tab is still on and active. Moving on, multitasking. Multitasking is an important concept that allows an operating system to run multiple processes simultaneously. Just now, as I explained, a single core CPU is done through a rapid switching between tasks. On multi core CPU, a through parallel execution occurs. A single CPU can only do rapidly switch between tasks, like for example, if it's reading from a document and then it's set to be print that document, it is going to go back and forth for this task. If we have multi-core CPU, which is the modern computing that we use right now, the laptops you're using, it has multiple CPUs. It is going to have multiple cores, that is, one is going to read, one is going to print, so a single core is not going to have so much load on it. The task is distributed across the cores. The operating system balances the load, ensuring efficient and responsive system performance. Moving on to multitasking, what does it exactly do? It capabilities of a CPU and its cores. When an operating system performs multitasking, it can assign different tasks to different cores. Where in short, if you're telling about different tasks that are running, that are different programs are running, and as I said, the program when it runs, it becomes a process. When a process has multiple threads, so basically this is saying there are multiple threads running together. This part, multiple threads running together, it is known as parallelism, a very important concept in multi-threading that we are going to learn. Sorry for my pen. Parallelism. So this concept is what I'm talking about right now. Moving on to our important concept, multi-threading. We know what the basics of what is multitasking, what is a CPU, what's a process, what's a task, what's a program. Now let's understand multi-threading. Multi-threading refers to the ability to execute multiple threads within a single process concurrently. Multiple threads running together and in a single process concurrently. Now, a web browser can use multi-threading by having separate threads for rendering the pages, running JavaScript, managing user inputs. This makes the browser more responsive and efficient. Moving on, multitasking can be achieved through multi-threading, which is pretty self-explanatory, where each task is divided into threads and they are managed concurrently. Concurrency and parallelism are two important properties of a thread. That is, they can be managed concurrently and they can be run together, which is in parallel, which is known as parallelism. While multitasking typically refers to the running of multiple applications, multi-threading is more granular, dealing with multiple threads within the same application. Multitasking here, it refers to the running of multiple applications, whereas multi-threading is basically more granular. It deals with multiple threads within the same application or process. Why do we exactly use multi-threading? Basically, there are four more reasons. It gives us a better performance, it gives us responsiveness, it gives us efficient CPU usage. Imagine, like, if you have a single core switching between tasks, your CPU is going to be overheated. Instead, it is not going to be used efficiently. Overheating is a wrong word. It cannot be used efficiently. So multitasking basically allows the CPU to be more efficient. Real world application, it is used in web servers, games, Android development, and banking. So let's quickly take an example of an office manager. For example, there is an office manager called as operating system. It assigns different employees, that is the different processes, to work on different projects. For example, applications. Each employee works on a different project independently, making it more efficient. Many employees are going to get many tasks done. So when a single project application, a process of employees works on different parts of the project at the same time, collaborating and sharing resources. Sharing resources is very important in this. Now, if you dig a little deep in operating system, sharing resources can also lead to deadlocks, which is again a concept that you need to be aware of. Deadlocks are an important concept when you're studying multi-threading. Other than that, operating system, it's a process, user input, spell checker, there's a process, it plays music and basically plays YouTube. Now in Java, multi-threading is a concurrent execution of two or more threads, maximize the utilization of Java multi-threading capabilities. They are part of Java Lang package, making it easy to implement concurrent execution. Now in single core environment, as we discussed, Java's multi-threading is managed by JVM. JVM is known as the Java Virtual Machine. Java Virtual Machine. So in this and the operating system is switched between the threads gives us the illusion of concurrency. Basically, it gives an illusion of concurrency. The threads share single core and the time slicing used to manage thread execution. Basically, the threads is the single core environment. As I explained, it is going to give an illusion of concurrency. The same processor is going to switch between two processors back and forth, and time slicing is used. Time slicing, basically how this is done, again, if you're studying in detail about operating system, there is going to be a uh, sorry round robin algorithm a round robin algorithm which allows the time slicing. That is, each process is going to have one time slot, second time slot, third time slot, one fourth time slot. Round robin is a very important algorithm when you're studying about multi-threading in detail. It manages the thread time slicing. Again, multi-core environment, modern CPUs, Java's multi-threading takes full advantage of the available cores. Now, for example, I currently have NVIDIA's GPU laptop. So I have multiple cores in my laptop and also a GPU processor. So basically, Java's multi-threading is going to make full use of my laptop. It's a gaming laptop. I can run multiple tasks together. So the JVM, what does the JVM do? It distributes the threads across multiple cores, allowing a true parallel execution of threads. That's it. What are we going to do right now is we are going to do understand our problem, and then we are going to use coding to implement it. First, we're going to understand the program. Basically, we are supposed to write a Java program of multi-threading where two threads are going to execute concurrently. In this example, we will use the runnable interface. Runnable interface we are going to do, because of the time constraint, I'm going to quickly start the coding. You can implement threads in two ways. Basically, there is going to be a runnable interface, and then you can also implement threads by using extends runnable interface. That is the one type of thread. Second, you can just use the thread class. There are two ways to implement multi-threading or threads in Java: by using my runnable interface and by extending the thread class. Okay. First is extending the thread class, and second is using the runnable interface. Okay, so we are quickly going to create two classes. One thread is going to print the odd numbers from 1 to 10, and second thread is going to use the 1 to 10. The goal is how multi-threading runs independently in the same Java program. We are also going to use the volatile keyword in this to understand it in more detail. Volatile or synchronized keyword. Okay, now let's start the code execution. This program creates a thread to print odd numbers from 1 to 10. This class is implementing runnable interface so that the logic runs inside the run method. The thread runs independently for other threads, and the thread.sleep slows execution to show that the thread switching clearly. Output order is not guaranteed due to concurrent execution. Now, even program is similar. This class will create to print even numbers from 1 to 10. It also implements the runnable interface. You can use the extends keyword, the other method, to create a thread. There are two methods, as I said. Both odd and even threads run at the same time, and the CPU decides which thread executes first at runtime. This causes mixed and unpredictable output. This class is used to define a separate unit of work that will be executed by a thread, which is why it implements the runnable interface. Implementing runnable meaning that we have to provide a run method, and this method contains the code that runs when the thread starts. Inside the run method, a for loop runs from 1 to 10. For each number, if condition checks whether the number is using odd, using the modulo operator. If the condition is true, the number is printed along the thread label. After printing thread.sleep, 500 milliseconds pauses the thread for half a second. This pause is intentional. It slows down the execution so we can clearly see how many multiple threads switch and execute in parallel. The try and catch block is required for thread.sleep can throw an exception. Handling this exception ensures that the program does not crash during execution. Overall, this class does not create a thread by itself. It only defines a task. The actual thread is created later using the thread class in the main method. Now, for similar event tasks, the class defines a task that will run inside a separate thread, which is why it implements the runnable interface. By implementing runnable interface, the class provides a run method that contains the code executed when the thread starts. Inside the run method, a for loop runs from 1 to 10. For each number, the if condition checks whether the number is even using I modulo 2. If the condition is true, the number is printed with the label as even thread. And also thread.sleep will give 500 millisecond, pauses the execution of the current thread for 500 millisecond. This delay helps slow down the output, so we can clearly observe how uh, threads switch during multi-threading. And the try and catch block is required because thread.sleep can throw an exception. Handling this exception ensures that the thread continues running safely without crashing the program. Overall, this class only defines the work of the even number thread. The actual thread is then later created in the main method using thread class. The main method is the starting point of the program where threads are created and executed. First object of the odd number task, and we are going to define the class. We are going to create a constructor. We're going to give an object similar for the even number task. Next, each task is passed to a thread object. Creating a thread object does not start the thread, it only prepares it. Now, when the start is called in each thread, the JVM creates new call stacks and executes the run method concurrently. This is what enables multi-threading. Both threads now run in parallel, and the CPU, that is the Java virtual machine, decides the execution order. As you can see the output, we have not used the synchronize keyword yet, which means that the both threads run completely independently. The Java virtual machine decides which thread gets CPU at any moment. Because of this, the output appears mixed and unpredictable. Sometimes the odd thread prints first, sometimes the even thread prints first. For example, we may see even numbers printed first, followed by multiple odd numbers, and then even numbers again. This behavior confirms that the true multi-threading is happening and the execution order is controlled by the Java virtual machine. We are using synchronize keyword now. Synchronize keyword is used to control access to critical sections of the code. It ensures that only one thread can execute a synchronize method or block at any time on the same object. When a thread enters a synchronize method, it acquires a lock on the object. The other threads must wait until that lock is released. Synchronization works only when multiple threads share the same object. If the thread are working on different objects, synchronization will not block them. Now, as you can see, uh, the demonstration, basically this gives a simple demonstration that in a synchronized version we are adding synchronized keyword. However, the thread still runs on different object. So even though the method is synchronized, both threads acquire different locks, therefore they do not block each other. Because of this, the output still appears mixed. If we want to use synchronize, because of the time constraint, again the synchronized keyword can be implemented by adding synchronize, and the locks must be shared of both the methods. Then you can see even method and odd number and even number and odd number and even number running one after one.